of best fit. So we're going to write an equation for the line of best fit for the scatter plot shown below, then use the equation to predict the exam score for someone who spent 7 hours watching TV. There is no trend line drawn for you. So because we have the calculator, we are going to come up with the equation of a trend line by ourselves. The first thing we need to do is write out all of the ordered pairs. So this is at 0.5, 90. You are estimating. I do understand that. Just give it your best shot. 1, maybe 87. Here, this is at 3, maybe 71. We have 3.5, 70. 4, maybe 64. And then over here at 6, I'm going to say 58. All right, I have all of my ordered pairs written out. So now it is time to use our calculator. So the first thing that we are going to do is to clear all of the lists. To do that, I'm going to hit second plus 4, enter. You get a message that says clear all lists done. Then I'm going to go into stat, hit enter. I'm going to put all of my x values in list 1. So if this black bar is not in list 1, you need to use the arrow key. And then I'm going to type 0.5, 1, 3, 3.5, 4, and 6. Then I'm going to use my arrow key to move over to list 2 and type my y values. So we have 90, 87, 71, 70, 64, and 58. Okay, now all of that is completed. I need to calculate the linear regression. So we're going to hit stat, use the right arrow to go over to calc. Then you're going to hit 4, enter until the screen changes. And look, I get a message that has y equals ax plus b, a number for a, and a number for b. So all of our equations are in this format. I'm going to round to the hundredths place. So y is equal to negative 6.15, because this 6 in the thousandths place is going to bump that 4 up. X plus b, I'm going to say 91.77. Now I have an equation for this line that will go through these points. So I need to use it to predict the exam score of someone who spent 7 hours watching TV. Okay, well, the first thing I need to determine is 7 hours x or is it y? Well, hours is on the x, so that 7 is going to be an x value. That means I'm going to plug 7 in place of x, and then I'm just going to solve for y. So we have y is equal to negative 6.15. Between this negative 6.15 and the x, they are being multiplied. So I'm going to say times 7, because that's what I'm plugging in for x. And then plus, we have 91.77. Now I can just type this part of the equation into the calculator, and it will give me my predicted exam score. Type it just like you wrote it. And so they're predicting that you'll make a 48.72, which for a test grade, I'd probably round that up to a 49%. Not very good for spending that much time watching TV. All right, our second question here, it says Eric works in a restaurant. Sometimes he clears tables. The scatter plot shows how much he earned in tips by clearing tables in different ways. Which statement would be the best prediction for how much Eric would earn for cleaning tables? Well, let's first see if any of these points are actually on the graph. Eric will earn about $10 for clearing 6 tables. Okay, dollars is the y, so looking at 10 and see if that's about 6. Yeah, that doesn't look too bad. Let's see if there's a better answer. Eric will earn about $6 for clearing 6 tables. Well, 6 tables, our point is up here, so I don't think $6 is very accurate. Eric will earn about $12 for clearing 11 tables. So 11 tables is between 10 and 12. And it looks like I'm just shy here of $16. So I think $12 is a little low. Eric will earn $16 for clearing 13 tables. Well, if I'm almost at 16 for 11, you'd think you'd be earning more for 13 tables. So I would say A is the best choice. Okay, this last one, it shows the line on the scatter plot. So we're going to do something a little bit different. You can, of course, use the calculator if you would like, but you do not have to. The scatter plot shows the foot lengths and forearm lengths for a group of people. The trend line of the data is shown. Based on the scatter plot, what is the best prediction for a person's foot length in inches if their forearm is 13 inches? Well, lucky for us, forearm 13 inches, well, forearm is Y. 13 on the Y is on the graph. So I could estimate that their foot length is probably about 12.5 because it's in between 12 and 13. Now, if the line was drawn and the length was not on the graph, what I could do is I'm going to pick 2 points that are exactly on the graph. Now, these points do not have to be your actual points in the data. This one actually does happen to be a data point, so I'm going to choose that one. But then I'm going to pick a point on the line where it perfectly intersects. And I can see here, it perfectly intersects here. So although it's not a data point, I'm going to use that point to find the slope. So the ordered pair for this one is 7, 7. And the ordered pair for that other point is 9, 9. So to find the slope, I'm going to make an XY table. 7, 7, 9, 9. To go from 7 to 9, I add 2. To go from 7 to 9, I add 2. My slope is change in y over change in x, so 2 over 2, which just simplifies to 1. All of our equations are in y is equal to mx plus b, where m is our slope. So I just found our slope, y is equal to 1x, which is just x, plus b. All right. Now, to find the y-intercept, because it's not quite on the graph, I'm going to go ahead and use some of our points that we had and plug in. So I'm going to plug in 7 for y, 7 for x, plus b. Well, 7, it should be at 0, but it doesn't quite look like it's at 0. So maybe I didn't pick the best points for the line. But in theory, your y-intercept would be on the y-axis. So then I would be able to choose that y-intercept as well. So I'm going to write the equation y equals x, which is the one I got because x plus 0 is just x. So I'm going to say if it's 13 for y, well, that must also be 13 for x. Well, originally we said it was about 12.5. So 12.5 and 13 are pretty close together. So even though our equation of the line was not perfect, I still was able to use it to estimate. All right, ladies and gentlemen, that is it. Thank you.